Okay, class, now we want to look at these half angle formulas. Whereas we helped derive and see why the double angle formulas worked, we're just going to go ahead and put these to use here. So this tells us that if I have a cosine of an angle that doesn't appear on the unit circle, if I can make it a half angle so that the alpha part does appear on the unit circle, which is exactly what we can do here. If we think of 15 degrees as 30 degrees divided by 2, because 15 degrees is half of the angle 30, and now 30 comes in as our alpha for the negative. So we're looking at cosine here for this first one. Okay, one thing we want to look at to begin with here is that the angle that we're interested in a cosine for is 15 degrees. Now we do know that that's just going to stretch up here into the first quadrant, and in the first quadrant cosine is positive and sine is positive because x and y are both positive. So even though this says this is plus or minus, we're only going to keep the plus part because cosine of 15 degrees is definitely positive. Okay, so now we've got this in form where we can plug it in. So we're going to take the positive result from a square root of 1 plus the cosine of 30 degrees over 2. Okay, so square root of 3 over 2 is the cosine of 30 degrees. Okay, and the next thing I want to do is remove the complex fraction. If I multiply a 2 on top and a 2 on bottom, it's again what we call a well-chosen 1. Multiply anything by 1 and it retains its identity. So distributing this 2, I get 2 plus 2 times the square root of 3 over 2, which simplifies to a square root of 3. But down here I now have 2 times 2, or 4. Okay, so the last thing I might want to do here is use the fact that the square root of 4 is 2 to simplify this further and write that as a square root of 2 plus a square root of 3. Nested square roots. Square root of 4 is 2, so I can just put a 2 on here. Okay, so the exact value for the cosine of 15 degrees is the positive square root of 2 plus the square root of 3 over 2. Now for part B down here, we're asked for the sine of negative 15 degrees. Again, we can just identify the quadrant that that's going to be in. Negative 15 degrees will take me down here into quadrant 4 where we have a positive cosine but a negative sign. Okay, so let's rewrite this as a sine of negative 30 degrees over 2. Okay, and I could, if I wanted to, use the odd property of the sign and take the negative out in front and write it as negative sine of positive 30 over 2. I'm going to choose to do it this way instead. I'm going to say, okay, I know I want the negative result of, and in this case we're looking at a sine of alpha over 2, so we're up here. But we want the negative result of 1 minus a cosine of negative 30 degrees. And all of that is over 2. Okay, so the cosine is even, so remember the cosine of negative 30 degrees is identical to the cosine of 30 degrees, and you can see that right here. Okay, so the cosine is the positive on the right half of the coordinate plane. So we're going to go ahead and write this then as the negative square root of 1 minus the cosine of 30 degrees over 2, or just look at the angle that coincides with negative 30 degrees, which would be 330 degrees, and its cosine is the square root of 3 over 2, and the cosine of 30 degrees is also the square root of 3 over 2. So we're going to get either way negative 1 minus the square root of 3 over 2, all of that over 2. And I'm going to do the same thing to remove the complex fraction. I'll multiply by a well-chosen 1. So the end result here, I'm going to have a negative square root of 2 minus square root of 3 over 4. And again, I'm going to simplify that radical 4 in the denominator, and so this will be a negative square root of 2 minus the square root of 3 over 2.